Hello and welcome. In today's video, we're going to be talking about indices and raising numbers to a power. First, let's talk about multiplication. So, we have seen if you have a number, let's say 2, raised to a power, let's make it 3, we can rewrite this as 2 times by 2 times by 2. All right? Now, one other way you can visualize it is 2 to the power of 1 times by 2 to the power of 1 times by 2 to the power of 1. 2 to the power of 1 is the same as 2. Any number raised to the power of 1 is itself. So you could have 5 to the 1, 7 to the 1, it's still equal to itself. Now, as you can see, these indices, these powers, which are these numbers, they will give us 3. So it will be 1 times 2 to the 1 times 2 to the 1 is equal to 2 cubed. And if we remove all these 2's, we can see that 1 plus 1 plus 1 is equal to 3. So that is our very first rule. When we multiply two numbers that have the same base, so the same number here, we add the powers. Let me give you one more example. Let's say we have a cubed times by a to the 7. So in this case, we have a variable, but we can treat it as any number. Now, we'll take our 3 and our 7, and we're going to add them together, which will give us 10. Okay? Now the bases stay the same, and we're going to get a to the power of 3 plus 7, which is a to the 10, all right? Which again is a times by a times by a, and so on for 10 lots. Now what happens if we have a to the minus 6 times by a to the 9? Now, we have a negative power. When dealing with negative powers, we can rewrite this as 1 over a to the 6. This negative sign means that this is a fraction, so 1 over. Now, this is just for visualization. We will keep this in this form for calculation. So we will get, just like normal, we will add these two powers together. So we'll get minus 6 plus 9, which is equal to 3, okay? So we'll get a to the power of 3, which is the same thing as a to the minus 6 times by a to the 9. Now let's take a look at division. Let's say we have a to the 9 divided by a to the 6. Okay. Now with multiplication, what we did was we add the powers. So with division, we're going to minus the powers. Now earlier I said a to the minus 6 is equal to 1 over a to the 6. So we can rewrite this as a to the 9 multiplied by a to the minus 6, which again gives us a to the 3. Let's look at another problem. B to the 12 over b to the 7. So we can rewrite this as b to the 12 times by b to the minus 7. 12 minus 7 is equal to 5. This would give us b to the power of 5. Let's look at a different problem here. Now we have two variables, a and b. So let's rewrite this again. So we have a to the 9, b to the 7, times by a to the minus 2, b to the minus 5. Okay, that is the same thing as this up here. Now, normally we're just used to seeing one variable, but in this case we really just treat it as the same. So this term will be added to this term, and the b term will be added to the b term, because the a and the b variables have nothing to do with each other. So we're going to do 9 minus 2, which is 7, and we're going to do 7 minus 5, which is 2. So this is for your a terms, and this is for your b terms. Okay? And that will give us a to the 7 b squared. Okay? Now let's take a look at fractional indices. As you can see here, we have 4 to the power of 3 over 2. Now, this is another different type of rule. When we have fractional indices, we need to remember that this number is going to root the number, and this number up here above the fraction, the numerator, is going to cube or multiply this number by itself. So first what we're going to do is we're going to take a look at the denominator, this number 2. Now 2 is going to be the square root, okay? If this were a 3, then it would be the cubed root. So our first step is going to be to square root 4. And we know that the square root of 4 is equal to 2, okay? So now that we've gotten rid of this denominator, we will then be left with 2 cubed, okay? And that we can figure out as 8. So 4 to the power of 3 over 2 is equal to 8. Now let's take a look at this problem. This one is slightly different here, as we have a variable b to the power of 8, and all of this to the power of 3 over 2. Now this is one extra rule here. When we are having a number, let's say x to the power of 3 over another number, let's say 4. These two numbers here, instead of adding them, we're going to multiply them. So this will be 3 times by 4, which is 12. So this would be x to the power of 12. So applying this same rule for this one, we will get b to the 8. Now that we have a fraction though, we are going to divide by 2 and then times by 3. So it's going to be 8 divided by 2, which is equal to 4. So then we'll get b to the 4 all cubed, okay? Now, 4 times by 3 is equal to 12. And this will give us b to the 12. Notice that we did not change anything with the b number, okay? We only changed the power. If, however, this was 4b to the 8, 3 over 2, we would take the square root of b to the power of 8, but also the square root of 4, okay? And that would give us 2b to the 4, and then we would cube the b4, and we would cube the 2, okay? So this would be 2 cubed times by b to the 12, as we found out earlier here. So this would be 8b to the power of 12. Here are some example practice questions for you all to try to test your understanding. And feel free to pause the video. I'm going to go now through question 1. So 64, to the half. Okay, now, as the 2 is in our denominator, that means we are going to square root our number. Okay, so square root 64 is equal to 8. Okay, so an 8 to the power of 1, because that is what's left in the numerator, is still 8. So that is our answer for question 1. For question 2, p to the minus 4, all we're going to be doing, as you see this minus symbol, is we know that this will be a fraction, okay? So it's going to be 1 over p to the power of 4. And since this is a variable and not a number, that is where we'll leave it. So p to the minus 4 is equal to 1 over p to the 4. For question 3, we have 5 to the power of minus 2. First, let's turn this into a fraction. So we're going to get 1 over 5 squared. Now, we can evaluate 5 squared to be 25. And that will give us 1 over 25 for our answer. For question 4, we have 25 to the power of 3 over 2. First, we're going to square root, because that is in our denominator a 2. So that will be square root 25, which will be 5. And then 5 to the power of 3, as we have 3 in our numerator, we're going to do x cubed. So 5 cubed, which is going to equal 125. This last one, question 5, 100 to the half minus 64 to the third. This looks a little bit more difficult, but let's break this up. So we've got 100 to the half minus 64 to the third. So let's first do 100 to the power of a half. As the 2 is in the denominator, we're going to square root. So square root 100 is equal to 10. So this first part, part A, is equal to 10. So 10 minus 64 to the third. That looks a lot nicer. 64 to the third means you're going to take the cubed root of 64. And that will give us 4, because 4 times 4 is 16, and 16 times 4 is 64. So the cubed root of 64 is equal to 4. So that will give us 10 minus 4, which is equal to 6. Thank you for watching, and I'll see you all in the next one.